Welcome to O-Level Physics Online. In this video, I'll be talking about electromagnetic spectrum. And what I expect you to learn after watching this video are: one, you should be able to define the electromagnetic spectrum. You should be able to state the types of electromagnetic spectrum. Also, you should be able to state the arrangement of electromagnetic spectrum based on energy, frequency, as well as the wavelength. Also, you should be able to state the uses of electromagnetic spectrum, as well as what are the danger involved in using electromagnetic spectrum. If we look at the images I'm having here, talk of the laptop, the internet that we are getting from internet service provider, the radio set, the television, the dish we have for providing the opportunity for us to watch different channels on our television, looking at the remote control that we make use of, and the X-ray to check if somebody is having fracture. They are not just emanating from anywhere. They came from a particular source. And the source in which all these ones are from is what we refer to as an electromagnetic spectrum, or refer to as electromagnetic wave. Then, what is the meaning of electromagnetic spectrum? What is the meaning of an electromagnetic spectrum? Electromagnetic spectrum is defined as the range of all types of electromagnetic radiation. Now, if you can remember from what we have done in the previous video on wave, we said waves are classified into two types. We have what they call electromagnetic wave, then we have what they call mechanical waves. Mechanical waves, in quick, for us to review it quickly, we said they are those waves that do not, mechanical waves are those waves that require material medium for their propagation, meaning they cannot just travel in vacuum. They need something to transfer them from one place to another. So an example of mechanical waves are, we mentioned some of them already, which are water waves, wave in a string, as well as the sound wave. But for electromagnetic wave, it contains all electromagnetic radiation and they do not require any material medium for their propagation. I mentioned the range of all types of electromagnetic radiation. What are those all those electromagnetic radiation that I mentioned here? We'll be seeing it in the next slide I'm going to show to us now. However, what is the source of electromagnetic spectrum, or what is the source of electromagnetic radiation? From the name, we said electro, then we have magnetic spectrum. The term electro is derived from the term from the word electric field, while the term magnetic, from the name magnet, it is coined from. So that shows that electromagnetic radiation or electromagnetic spectrum is nothing than the combination of electric field and a magnetic field. I mentioned it here as what they are created as a result of vibration between an electric field as well as what a magnetic field. So when we have a kind of what a conjunction or joint or combination of electric field and magnetic field, in that case we have what they call electromagnetic spectrum, and they usually travel perpendicular to each other. Don't forget that they usually travel perpendicular to each other. Now, what are the types of electromagnetic radiation or spectrum? In the definition, I said it contains all the range of what electromagnetic radiation or spectrum. Remember, we can use the name interchangeably: electromagnetic spectrum, electromagnetic radiation, or we can call it electromagnetic wave. So I can use three of them interchangeably during the course of my explanation. Now, the types of electromagnetic radiation we have are: the first one we have is what they call the radio wave. Then we have what they call the microwaves. We have infrared. Then we have what they call the visible light. We have ultraviolet ray. Then we have what they call the X-ray. And the last one we have is what we call the gamma ray. So all these waves that I mentioned here, they are what we refer to as electromagnetic wave for our level. They are what we refer to as electromagnetic wave, or electromagnetic spectrum, or electromagnetic radiation, like as I've mentioned it earlier. Now, to remember the 7 for your exam, there's one simple code that we can make use of. And that code is what we call Re Mi Vox G. Re Mi Vox G. For you to remember all the 7 in the sequential order. They are what? Re Mi Vox G. The meaning of R, as you can see, R is the same thing as radio wave. M is the same thing as microwave. I that you have is the same thing as infrared radiation or infrared wave. Then we have the next one, which is visible light. Then we have ultraviolet ray, we have X-ray, then we have what they call gamma ray. So the sequence for you to remember them is what? Re Mi Vox G, Re Mi Vox G. So if you can remember Re Mi Vox G, then it will be very easy for you to list all of them down. Re Mi Vox G, radio wave, microwave, infrared wave, visible light, ultraviolet, then we have X-ray and the gamma ray. Now let us look at them one after the other. Let us differentiate between all these waves. Based on sequence, one of the common things they usually asking is a very common question in either in WAEC, UTME, or in NECO, even as well as IGCSEs. They usually ask students to either arrange them in the order, or they'll give you an objective exam and ask you on which arrangement this particular way given in the exam is based on. So let's look at them one after the other. Now, if you look at this, the waveform I'm having here, it represents how the vibration for a different type of wave usually appear. For radio wave, you will notice that the gap we have between the trough and the crest is a bit wide. And if you look at the extreme end here, they are what? Joined together. They are very tightly packed with one another here when you look at the wave that we have toward the end, which is toward the end of our gamma rays here. So what we notice from here, what you can just mention from here is that the distance between successive crests, between this top, the crest here, and the next crest here is very, very wide. And remember, the distance between successive crests, or distance between two successive trough, is what we refer to as wavelength. So that shows that we have longer, or the longest wavelength toward this end here. Meaning, as we are coming from the extreme end here toward the end part here, we have this increase in terms of wavelength from the gamma ray to the radio wave. From the gamma ray to the radio wave, we have increase in wavelength. Meaning, if you are coming from radio wave to the gamma ray, the wavelengths are decreasing. So that shows that if I'm comparing gamma ray and radio waves, you will notice that gamma ray has a shortest wavelength, while radio wave has the what? The longest wavelength. That is the first point. Then the second point we can see derived from this is that the time taken for this one to complete one oscillation, which is what we refer to as frequency, the time taken for this one to complete an oscillation here is going to be very, very small. I'm sorry, it's going to be very, very low. The time taken for this one is going to be very, very low. While time taken for this one to complete an oscillation here is going to be very, very high, because it's rotating. I mean, the level at which vibration is taking place here will be very, very fast, because they are tightly packed with each other. So in summary, what I'm trying to say is that for the wavelength we have mentioned earlier, that the radio wave has the longest wavelength, while the gamma ray has the shortest wavelength. But on the other way around, frequency, in terms of frequency, gamma ray has the highest frequency, while the radio wave has the lowest frequency. So if I'm comparing, let's take example, I'm comparing visible light and microwave. Visible light and microwave. Because visible light is very close or closer to a gamma ray compared to microwave, automatically visible light is going to have the higher frequency compared to that of the microwave. So what I can just deduce from here is that unlike the wavelength that we said that from the radio wave it is decreasing toward the gamma ray, but if you compare the frequency is increasing toward the gamma ray, meaning that microwave is having a higher frequency compared to radio, infrared is having higher compared to microwave, while visible light is having higher compared to infrared, up to the end like that. And this is what I summarize regarding this one. In terms of the energy, according to our Einstein photoelectric equation, we have E equals to HF, where H is constant. E is the same thing as energy, H is the same thing as the Planck constant, while F is the same thing as the frequency. Now, if you look at this, we have direct proportional relationship between energy and frequency here. Meaning, the higher the energy, the higher the frequency, or the higher the frequency, the higher the energy you are going to have in this place is going to be. So what you can deduce from that is that any of this radiation that has a high frequency is going to have the high energy as well. So that shows that since gamma ray is having the highest frequency, automatically it's going to have the highest energy. Y is going to have the lowest wavelength. So that's what you can just deduce from this one. So in summary, if we are comparing the increase in terms of increase in wavelength, the wavelength is increasing from gamma to radio. In terms of frequency, the frequency is increasing from radio to gamma, while in terms of energy also, the energy is increasing from radio to gamma. So if you are talking about the one that have the lowest energy now, it is radio wave. The one that have the lowest frequency, it is radio wave. While the one that have the longest wavelength, it is a radio wave like this. So it is very, very important that you take note of this order, as you are going to see in the equation that will post on the part of the description you have on this video. Now let's move on. What are the properties of electromagnetic radiation? What are the properties of electromagnetic radiation? From the definition I stated earlier, I said we have two types of wave. I said we have electromagnetic wave, then we have what we call the mechanical wave in terms of whether required material medium is required or not. We say mechanical wave require material medium for it to travel, meaning mechanical wave cannot travel in vacuum. That's the first point. They require something for them to travel. So let's look at this now, state other property that we have regarding electromagnetic wave or radiation. So the first one we have is what? They are all what? Transverse waves. So, and it's a common statement that you should remember that all electromagnetic waves are transverse waves, but not all transverse waves are electromagnetic waves. All electromagnetic waves, radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray, all of them, they are what? Transverse wave, meaning they travel perpendicular to the source producing them. So if the wave is traveling in perpendicular manner, like upward and downward like this, if the source of propagation is upward and downward, they are going to travel in the what? In the horizontal direction. If we are producing the wave, electromagnetic wave vertically, they are going to travel horizontally. So they travel perpendicular to the source producing them. And they are all what? Transverse. The second point is that because they travel in vacuum, all of them travel in vacuum in empty space. So as such, they travel with the same speed, 3 times 10 raised to the power of 8 meters per second. They travel with speed of light. But if they are in what? In material, sometimes passing through a material can affect them a little. And that is why, if you notice, if you are in a house that is, if your house is surrounded with mountain, as an instance, and you are the source of the internet that you are making use of is far from you, or is the other side of the barrier, there's a tendency that you're going to have little obstacle in terms of the wave that you're generating. That shows that despite the fact that they travel in vacuum, they can still be affected by what? By a barrier a little. They can still be affected a little by what? By barrier. But in summary, all of them travel in vacuum. They travel at the same speed, and that is speed of light, 3 times 10 raised to the power of 8. And the third one, they can travel in a vacuum. I think I mentioned that one already. They do not require material medium for them to travel as such. They can travel in a vacuum. The first property is that they can undergo all the properties of wave, ranging from reflection, refraction, diffraction, interference, and polarization. And all electromagnetic waves can be polarized. That's another very important fact. All electromagnetic waves can be polarized. And the fifth property that we have is what? They transfer energy from one place to another. Because they are wave, we say wave is a disturbance that travels through a medium and transfers energy from one point to another. And because all electromagnetic radiation are waves as well, so as such they transfer energy from one place to another. They transfer energy from one place to another. And the next one is what? They can either be emitted or absorbed. If you point them toward the material, they can absorb that material, or they can what? Emit from a material as well. So those are the properties of electromagnetic wave in summary. Now, what are the applications of all these waves that we are mentioning? Rimi Vox G. What are the applications? So I will cite them one after the other. The first one we have is radio waves. Basically, they are used for what? For communication, to be precise, for telecommunication, to be precise, in radio broadcasting, whether in radio or in television, in wireless telegraphy. Maybe if you are talking about your headset and so on like that, that's what we mean by wireless telegraphy. We have telephone transmission as well. Then we have in television set as well as what? Radar. So these are the main applications of it. So radio basically are used for what? For telecommunication. Radio broadcasting, wireless telegraphy, telephone, television, then we have radar. So those are the major applications, and that's why I put the picture here. If you look at, if you are talking about wireless communication using your Wi-Fi and so on like that, they work based on radio wave, GPS, satellite, radio. Then we have our cell phone, talking normal phone that we are making use of. Then we have the television set. All of them works based on what? Radio waves. Then the next one we have is microwave. I think this one is not common to us. It's having a yummy food inside. So what to use them basically for is what? To eat food. That is one of the common application of. However, the application of microwaves, they are not limited to the gadgets that we use for eating our food at home, or for us to warm our food at home. It's not limited to that. They are used also to receive television programs via satellite in the space. So they can still use microwave in space to transmit signals from space to what? To the Earth surface, so that we can get information about what is going on or what in space. Then the next one we have is infrared. So there's no doubt that if you look at the common remotes that we have, at home, there's something in form of LED like LED or bulb at the front of it. What that LED is functioning on is what they call infrared radiation. And in the ancient period, we have something that people usually make use of. If they want to transfer material, maybe information from one place to another, it is a common thing that they are going to take the one phone and take it to the second one. They'll be very aligned with each other, saying that they have to take the infrared to each other for them to join the infrared, for them to transfer material from one phone or to transfer data from one phone to another. So what they are making use of then is what is another application of what infrared radiation. However, other application we have is in what aside remote control in video, in Wi-Fi and so on like that. We can still use them in military and in defense. So how they use it in military and defense is that there are some goggles that when they put it on, even if they're in a dark place, they can still see the heat energy, the radiation coming from any object or living material they are having around them. And that's the example I'm having here. This is a dog. If they make use of infrared camera, it's going to show something totally different, showing the kind of radiation coming from that object to show that there's a living material at the front, and it can capture something that ordinary eye cannot see. So that's another application of this particular one. So in summary, I mentioned two applications here: one in remote control, the second one in military, such as in night goggle and in infrared camera. The fourth one we have is visible light. Visible light comprises of it comprises of all the light that we can see, and among all the radiation that we have, the only one that is common that we can see visibly or that we can see clearly among all of them is visible light. It is made up of all the light spectrum. That is Roy beef. Don't forget that. That is red, orange, yellow, green, blue. What's it called? Blue, indigo, and violet. So all these one are example of what visible light, and their main function is what they produce sensation of seeing, and they produce what they call radiant energy. The next one we have is ultraviolet ray. Ultraviolet ray is similar to that of what visible light. The only difference we have between ultraviolet ray and visible light is that for ultraviolet ray, it has higher energy. It has higher energy compared to ordinary visible light. So, and we'll use them basically for sterilization of what device that we have in the hospital, or to kill germs generally. So that's what we use ultraviolet for. Then we have X-ray. This one is very common. They are produced as a result of fast-moving electron. They are produced as a result of what fast-moving electron, and it was generated by a scientist known as what Roentgen's gene, which we'll be discussing later in one of our videos, inshallah. So X-ray are used in hospital for taking photograph of internal organs and broken bones. So to locate fracture in bone or in if somebody is having fracture, or if there's any problem somebody is having regarding his internal organ, we use X-ray basically to do that. We use X-ray basically to do that. It is also used in industry to investigate crack in the metal works. To notice if there's any broken part in a metal work, they can make use of X-ray for that. And aside this one, they can use it in either in the airport or in the mall to locate if there's any gadget or something to investigate or to check material that people are having in their luggage. Then we have the last one is gamma ray. Gamma ray is also an electromagnetic radiation. They result from what? From radioactive decay of atomic material or atomic nuclei. So they are what? They arise from radioactive. They among them, the one that is more radioactive is what is gamma ray. And we use them basically to treat cancer, to kill cancerous cell, and for quality control as well. So using gamma knife radiosurgery, we can use gamma ray to treat cancer, as you can see from here, like this. So those are the major applications of electromagnetic wave in the sequential. So you should be able to know their applications. Now, what are the dangers involved? What are the dangers involved in making use of electromagnetic wave? The first one, radio wave, that are used for our phone, for our gadgets, and so on like that. They have no known danger, and this one will clarify the point that people were spreading around regarding the issue of COVID-19, that COVID-19 actually is as a result of 5G network and some other stuff like that. Of course, it has no relationship with that, because the internet that we are making use of, they are resulted from radio wave. And radio wave has no known danger. As such, we cannot mention that because COVID-19 is trending and some other things, because we are working on generating 5G, that is what results into what we call COVID-19. So, but that's not reliable, or it's not verifiable, or it's not a fact at all. Then we have microwave. Microwave produces what? Heat energy. So what it can result to is what? It can damage internal organ or can cause skin burn. So that's the effect of microwave. Then the next one we have is what? Infrared. Infrared, because we said it has what's it called? It's generated from heat energy. Basically, the source of it is what? Is heat energy. As such, it can burn skin. It can revert to what? To skin burn. Then we have visible light can cause eye damage. If somebody look into the sunlight, because the source of visible light is what? Either sunlight or bulb. So if you look at them directly, they can damage eye. Then we have ultraviolet ray. Ultraviolet ray, because it has higher energy, it can result into what? It can blind somebody's eye, or it can damage eye. It can cause skin burn. Also, it can result into skin cancer. Then we have what they call X-ray. X-ray, despite this function that we enable one to see the internal organ and so on like that, it is not advisable for somebody to use it consistently without any kind of any material to protect oneself, like lead coat. So it can kill cells within. It can cause genetic mutation, and it can result into cancer as well. And the last one we have is gamma ray. Just the same effect as well for X-ray as well. It can kill cells. It can cause genetic mutation as well. It can cause what they call what? It can cause what you call cancer as well. So these are the major defect or effect of what electromagnetic radiation that we're having that I mentioned to us earlier. So that is summary of what we have so far. So in summary, at the end, in summary of what I've talked about so far, we talk about electromagnetic wave. That is, they are wave that do not require material medium for their propagation. We said the example of them is Riemann Vox G, don't forget. Also, I mentioned that they are based on the energy. The one that has the highest energy is gamma. The one that has the highest frequency is gamma. The lowest wavelength is gamma as well. So take note of that. As well, we have talked about the application and the danger involved in using electromagnetics wave. So thank you for listening. This is summary of what you have for this video. So thank you for the audience given to me to listen to this short presentation. And don't forget to subscribe after you might have watched this video, and click on the like button. Thank you very much.